All right, so we're in Journal 21, and in this spell work here, all I'm asking you guys to do is to take these two factors and multiply them. So remember, we tried to do this on, I think it was Monday, as a bell work, and you guys said that you would distribute the terms. So some of you guys have done this in geometry and algebra. So in this case here, what you have to do is take the first term here and distribute that. So I'm going to go ahead and do that here. So x times x is x to the second power. But then we're not done distributing this x. This x is now distributed to the next term. So x times 4 is positive 4x. And then I have no more terms on this side. So now I have to go to the next term on this parentheses, the first parentheses, and distribute the negative 7. So I'm going to go ahead and do that. So negative 7 times x is negative 7x. And then negative 7 times 4 is negative 28. Now at this point, you would try to combine any like terms, like these two in the middle are both x to the first power. So the x squared comes down. The middle becomes negative 3x, right? Positive 4 minus 7 is negative 3. And then the negative 28 comes down. Now these are not like terms because these are different exponents, and this one's a constant, it's just a number. So this here is my final answer. So let's take a look at what we just created here. So I haven't mentioned this before, but if you have something that's one term, like let's say just 3x by itself and nothing like added to it or subtracted to it, then this is what we call a monomial. If you have something like this factor here and there are two terms inside, that's what we call a binomial. So mono means one, nomial means term. Bi means two, nomial means terms. So if you have three terms, well, that is a trinomial. So just thought I'd give you those types of vocabularies because you're going to notice that I'll use them very often. Another thing is we're going to describe what method we just used here. So this type of distributing is what we call the FOIL method. And I'll break that down to you. It's an acronym. So F stands for first. And it's because you're taking the first terms in each parentheses and multiplying them and getting that value. O stands for outer. I used green. O stands for outer. And that's because you're taking the outer terms of the parentheses and multiplying them. The x and the 4 would be considered the outer terms, and you multiply them to get 4x. Now, the next term here, the inner term, or I, it's kind of I here, what we call to the inner term, and that's because you're taking the inner numbers on the parentheses here and multiplying them and getting the next term here. And then last but not least, you have the last term multiplying each other. Notice how 7 and 4 are the last terms, and you multiply them to get the negative 28. So FOIL is talking about the 4 terms you create after you distribute it. And so then you would combine like terms to try to get probably like a trinomial. So let's take a look at some foiling problem. So in today's lesson, what we're going to be doing is actually going from a trinomial and finding the two factors. So we're actually going backwards today. But I wanted you guys to know how we came about this, and that's using foiling. All right, so here I have an outline of a trinomial. Because quadratics that we've seen before, this would be considered in standard form. I just don't have the A in front. But most quadratics are written in trinomial form. And what we have to do is figure out how to factor them. And so in this case here, I have two factors, and I'm going to go ahead and FOIL them and get to the trinomial, but I also want us to notice the pattern. So just kind of watch carefully here. So I'm going to distribute the first term. So x times x is x squared. X times 6 is 6x. And then I'm done distributing the x, so now I'm going to distribute the 1, and then I'm going to distribute to the 6, so that's going to be plus 1x, and then 6. And so if I combine like terms, which is just the middle part here, that's going to give me x squared plus 7x plus 6. All right, so let me just say something here. This last term that we made, the constant, well, turns out to get that number, we had to do 1 times 6. In other words, we had to multiply to get that last number, multiply. So what you'll do is find two factors that multiply to give you 6. And notice how to get the middle number, you had to add the 6 with the 1. So you will add the factors to get the middle term. So you multiply to get the last term, you add the factors to get the middle term. So now we're going to try to do this backwards. So what you have to do first is looking at the trinomial. Notice these are all quadratics. But this last number here, what two numbers make 20? What two factors multiply together make 20? Well, there is 2 times 10, 4 times 5, and then 20 times 1. And I think that's it. So out of these factors here, we know they will all multiply to give us 20, but which of them add to give us 9, because that helps us find the middle term? Well, the only ones that does that is the 4 and the 5, right? So let me lay that down. So x, 4, and 5. So I need x's because I need to make that quadratic. So x times x gives you x squared. And booyah, I got that quadratic. But in this case, I need to figure out the middle term and the last term need to work out. Now, what I notice is that this is a positive sign. So I need to make sure both of these will multiply to give me a positive, but then they need to add to give me a negative. So maybe a negative would work here, because negative times negative gives me a positive, but when I add them, I still get a negative 9. So if I were to go ahead and distribute this to see if this foils out to be that case, well, I would get x squared minus 5x, distribute the negative 4. That would give me negative 4x plus 20. And so it looks like the middle term here is negative 9x. And so there we do have it. The middle term does turn out to be the case when you add the two factors. All right, now let's try it with 80 here. Two numbers that make 80, maybe 8 and 10. There are other values that work here, but looking at it, 8 and 10 can add to be 2, right? If we make the signs different, notice how this 80 is a negative. Well, two numbers to multiply to make a negative number, that means that one of them needs to be a negative. But which one needs to be the negative sign, the 10 or the 8? So we know that both of these numbers need to multiply to make negative 80. That means one of them needs to be negative. So I'm looking at the middle number here, and I notice that it's a negative. So that means that the bigger number needs to be a negative number, because when I add, well, I want it to be negative. So the bigger number here is 10. So let's just try this out. So the 10 will be negative and 8 will be positive. Well, negative 10 times positive 8 gives me negative 80. Negative 10 added with 8 gives me negative 2x. So this works out. And if you don't believe me, go ahead and FOIL. So this would make 10x plus 8x minus 10x plus, minus 80. And I notice at the middle here, if I add 8x with negative 10x, I get negative 2x. So this does work. Let's try this for the last one here. So something that multiplies to give me 6, but adds to give me, well, this is a 1x. So how about 3 times 2? So 3 times 2 does multiply to give me 6, but this is a negative 6, which tells me that one of these is a negative. And And so I need to figure that out. But the middle term is a positive. That means the bigger number here needs to be a positive, which is the 3. And I guess the 2 needs to be a negative. So if I multiply 3 with 2, negative 2, I do get negative 6. If I add positive 3 with negative 2, I do get a positive 1. So this does seem to work. But I am going to FOIL it out just in case. I know you guys are probably getting tired of me foiling it out. But just to make sure that this pattern does work. So I get negative 2x plus 3x minus 6. And so it does look like the middle term will add to give me 1x. All right, so kind of wrap things up here. It looks like in order to factor a trinomial, the last term we're going to find its factors that multiply to give us that number, but then add to give us the middle term. All right, so we've learned one way of factoring. I'm going to teach you 2 more ways to factor. So this is the case when you get a binomial and you notice that the number here is what we call a perfect square. So 9 and 49 are called perfect squares because if you were to take the square root of them, you're going to get a whole number, okay? There's going to be a number that multiplies to give you that perfect square. So in this case here, the square root of 9, or 2 numbers that multiply give you 9, is 3, right? 3 times 3. So that means I can factor this as x, 3, and 3. But this here is a negative. That means one of these needs to be a negative. Since they're both the same types of number, it doesn't really matter which one is negative, which one is positive. But when I notice that I add these two, right? So when you multiply, you get negative 9. But when you add them, we learned that negative opposite signs and same coefficients cancel. So they would cancel. And so that means that you wouldn't have a middle term. So it looks like these are the factors, but just to make sure, let's FOIL this out. So if I FOIL x times x gives you x squared, x times 3 gives you 3x, and then if I multiply the negative 3, I would get negative 3x minus 9. And it does look like the middle terms cancel. They would subtract. And so leaving me with x squared minus 9, which tells me that this factor is does factor for this binomial. So in this case, anytime I have something that's a perfect square and there's a minus sign in between them, that means I can factor them and find what is the perfect square's root. So if I were to take the root of a squared, well, that would just be a. But one has to be a positive, one needs to be a negative so that the middle term cancels out. So like in number 2 here, the number that multiplies to give you 49 is 7 times 7. So that means I can split them up into 2 factors where both of them are 7, but one of them is a positive sign, the other is a negative sign. Now, keep in mind this only works when it's a perfect square with a minus sign. That's why it's called the difference of square. Now, there is no such thing as called the sum of perfect squares, okay? So if you had a case where, let's just pretend for a moment, you had a case where you had x squared plus 4. Now, we all know that 2 times 2 does give you 4. So people start factoring it like they used to. So x plus 4 and x plus 4. Sorry, not plus 4. Plus 2 and x plus 2. Because they can't be a minus sign or else they would give you a negative. So then people choose, oh, why not just make both of them positive? Well, here's the reason why. Let me scoot this in just a little bit. Because if you FOIL it out, let's see what you get. So foiling this out gives you x squared plus 2x, then you would get another 2x plus 4. Notice that the middle term here, when you add them, you would get 4x, then plus 4. And this here is not the same as this here. Notice how this is a trinomial and this is a binomial. It's because when you add 2 and 2, they don't cancel. So they are going to add to be 4x. And that causes it to have an extra term, where the beginning part, this did not have 3 terms, it only had 2. So my case is that anytime you have something that is a perfect square but there's a plus sign, it's actually not factorable. And so you could stop right there. So you can't factor it, is what I'm saying. All right, I'm going to teach you one more way of factoring in the next slide. So this slide here, I have, so we've been looking at problems where the coefficient for x squared is 1. Notice that if you look back at all the problems that we've done so far in this video, x squared's coefficient was a 1. But this time around, I've stuck in a 2. And so what do, right? So what do we do when a is not 1 is the case? Well, there's this method called slide and divide, which will help us out here. So basically, you want to slide your a over to C. And so what I mean by slide is you multiply your a times your c. So the first step here, if I move this to the 5, I drop down the x squared, so the 2 goes away because it's been slid over to 5. 11x drops down like normal. 2 times 5 gives me 10. So the first step is to slide by multiplying the a with the c, the last number with the first number. The second step, notice how now the coefficient in front of x squared is just a 1. So now you can go back to factoring like normal. And so if I were to factor this, I have to find 2 things that multiply to give me 10, 5 and 2, but they don't add to give me 11. 10 and 1 work though, right? So in this case, x, 10, 1, they're all positives here, so probably need to make all of these positive signs. 10 times 1 gives you 10. 10 added with 1 gives you 11. So this works out. But here's the thing. You multiplied this 2 to the 5 in the very beginning. So we need to undo that so we can go back to our original equation. So in this case, what I'm going to do as my third step is I'm going to divide. Hence the name, slide and divide. So we're going to divide by a, whatever number you multiplied in the beginning. So you're going to divide that by, so our a here is 2. So you're going to divide by 2 to both of the factors. Now, notice how the first factor divides nicely. 10 divided by 2 gives you 5, but the other one doesn't quite. And so what you would have to do is whatever the denominator is, you're going to multiply the denominator by everything. Well, when you do that, 2, this is a 2, so 2 times x gives you 2x plus 2 times 1/2. 1/2 as a decimal is about 0.5. If you multiply that by 2, you get 1. So my quick trick to doing this when you have something that doesn't divide nicely, just take the denominator. Instead of doing all that work that we just did, what you could do is just take the denominator and stick it in the front of x. And so now it's just 2x, and then just bring down the numerator like a whole number. And then now we have our factor. Let's practice this one more time so that way you guys get a feel. All right, so in this case here, my a, or the coefficient in front of x squared, is a 3, so I'm going to use slide and divide. So remember, the first step is to slide over. So you want to, multiply your a with your c. So x squared drops down minus 2x. Negative 3 times 15 gives you 3 times negative 5 gives you negative 15. And then numbers that multiply to give you 15 but add to give you negative 2, maybe 3, and 5 would work. Let's try that out. So step 2 is to factor. Well, it looks like the middle term here is a negative, so that means that the bigger number needs to be a negative, so the 3. And then the 2 will be a positive. So if you take negative, I think I messed up on my numbers, using the numbers from before. So the bigger number here is a 5, and the smaller number here is a 3. And so if you take negative 5 added with 3, you do get negative 2. So this does work out. But step 3, we do need to divide by the a value that we started with. So if I divide by 3, the first one doesn't divide nicely, so I'm going to stick it in the front. So this becomes 3x, the 5 just comes down. And this one does divide nicely, so 3 divided by 3 gives you 1. And so here is our factors. And that's it. And that's it for today's slide here. So there's no homework over this. The only pages now that are currently assigned are pages 1 to 3 on, so I'll write the little homework assignment that's currently. So homework packet 4, pages 1 through 3 are assigned. There are no homework assignment for this lesson, but we're going to do an activity on Friday. If you're not here for Friday, you'll just be exempt from the activity. But we're going to practice more of these factoring skills. All right, until next time, guys.